All right, so well, I'm just going to draw the shapes for this one, okay? So we're just going to have a look at what the shape should be. I would say that triangle, I would draw, we did over the whole trip, displacement between 0 and 7 seconds. So just here. Those are the shapes I would do. Okay, from 0 to 7 seconds. Whoa. I mean, there's other ways to do it. You could make this one big rectangle and this a smaller rectangle. You still get the same answer. Okay, so let's have a look at part A for this one first. We want to calculate acceleration. Remember that the formula for acceleration is the change in velocity, Vf minus Vi, over t. So between 7 and 9 seconds, we know the time is 2 seconds. Right? Then we'll just look up what our Vf and Vi are. Vf is 0. At time 9 seconds, the speed is 0. And at time 7 seconds, it's 3. Okay, so negative 3 over 2 is negative 1.5 meters per second squared. It's important that it's negative because that shows that it is accelerating backwards, even though it's moving forwards. Okay. Now, for the displacement between 0 seconds and 7 seconds. So we've already drawn the shapes for that, okay, but remember, we find the area of those shapes because that's taking our average velocity and multiplying it by time to get displacement. It's just on the triangles, we're using the average because it's changing. On a flat part, the average doesn't change. All right. So for the first triangle here, we have a base of 1, a height of 1, so 1 times 1 is 1, okay, divided by 2, that box is 0.5. Then I have this long box here, okay, that's got a height of 1 and a base of 6, so that one's going to be 6 meters. Then I've got this triangle here that has a base of 2 and a height of 2. Okay, so 2 times 2 is 4, over 2 is 2. Then I've got this box here that has a base of 3 and a height of 2, so that's 6 meters. And now I can add them all together, so 12, 14 and a half, positive 14 and a half meters. Okay. Now, average speed over the whole trip means I have one more shape that I have to find the area of, okay, because during this last 2 seconds, the object changes its velocity from 3 to 0, so the average velocity would be 1.5, okay, times 2 seconds, okay, so that'll be 3 meters. Okay, everybody all right with that? Okay, so now I can calculate the total distance and the total time because that's what I need to get average speed. So we already had 14.5 plus 3 is 17.5 meters, okay, and the total time is 9 seconds. Okay, so 17.5 over 9 should be 1.94 meters per second. Everybody all right with that one? Okay, and then lastly, the acceleration between 2 and 4 seconds. So we're back to this formula here. Okay, A equals Vf minus Vi over T. Vf is 3, Vi is 1, and that takes 2 seconds. 3 minus 1 is 2. Okay, so positive 1 meter per second squared. All right. Like I said before, that is definitely the kind of question I would put on a unit exam or a quiz. Okay, it's not as involved as the one that had 9 shapes for you to find. Okay, and on a test, I might not even ask you to do the whole thing. I might just ask, what's the average speed to time 4 seconds or something like that. Okay, it'd be a shorter graph. I just need to know that you can do it, not how fast you can do it. All right. So I'm going to put up the rest of them here. Actually, I think what I'd like you guys to do now is move on to the other ones. So back onto some position versus time graphs. So I'm going to put up the sheet I want you trying now. You'll probably need to call this one up on your phone because I won't be able to get much of it other than the graph on the screen here for you. Alright, so we just did that one. We're not doing the curve. We'll skip that one. Okay, so this one says kinematics assignment, but it's not coming in for marks. Okay, So we've got this position versus time graph here. Okay, got a bunch of different sections on it, and I can't even get the rest of this stuff on it. Okay, so the questions are under the graph on the next page. Okay, position. So question number 1 is basically just asking you, can you read the graph? Because after all, it is a position versus time graph, which is asking you what's the position at these times. Okay, and then the total displacement, and it says 2 seconds, to 4 seconds, to 11 seconds. That means from 0 to 2 seconds, from 0 to 4 seconds, from 0 to 11 seconds. All right, so that's what we're working on right now. Okay, and I'm going to go over those as we go along. Okay, this probably won't take very long because position versus time graphs are pretty straightforward. So let's just quickly look at number 1. I know you're probably all done that already, but just to review here. Okay, so what's the position at time 0 seconds according to this position versus time graph? Positive 30 meters. Okay. All right, at time 6 seconds, the position is, all right, so here's 6 seconds. All right, so the position is halfway in between 2 lines. So I think we're looking at negative 15 meters there. All right. And at 14 seconds, so here's time 14 seconds. All right, I think we're looking at positive 25 meters for that. All right, questions on number 1? So that one's just, can you read stuff off of a graph? Pretty straightforward. How many people have done number 2 with the displacement? Okay, let's look at that one then too. All right, to calculate total displacements, okay, remember that is final position minus initial position. So to time 2 seconds, our initial position actually for all of these is the same. It's positive 30. Okay, at 2 seconds, we are at a position of 50 meters. Okay, so for 2 seconds, it'll be 50 minus 30, okay, which is obviously a displacement of positive 20 meters. All right, to 4 seconds, we're down here at a position of 4 meters, it looks like. Okay, positive 4 meters. So we'll have positive 4, our final position, minus positive 30, okay, which will give us negative 26 meters as our displacement during that time interval. And then from 0 to 11 seconds, so at time 11 seconds, we're right here at 0. So our total displacement will be negative 30 meters. Because we started at positive 30 and are now back at 0. Okay, everybody all right with that? Okay, so final position minus initial position. Okay, and then on number 3, you have to calculate the total distance for all the same times as in question 2. So from 0 to 2 seconds, from 0 to 4 seconds, and from 0 to 11 seconds. All right, give you a couple minutes on that one. Or are we already done that? People are done. So total distance traveled, okay, is a slightly different calculation, even though from 0 to 2 seconds, it's actually the same number. Right? Because from 0 to 2 seconds, we go from 30 to 50, which is 20 meters. But when we go from 0 to 4 seconds, now it's going to be different because the object changed direction and started backtracking. And now the scalar versus vector differences come in. So we had 20 meters here, and then we went from 50 down to 4, and that's 46 meters. So in total, between 0 and 4 seconds, the distance is 66 meters. Okay, everybody okay with that? All right, and then to 11 seconds, we got to keep going. So from 4 to negative 42. Okay, so that should be negative 40, or just actually 46 in there. And then to 11 seconds, another 40 meters. Sorry, another 42 meters. Okay, so 88 and 46. 128, 134, and 64. I think that's what it is. 164 meters. Okay, I'll let you get ahead of me again. Those aren't hard. 154, did I mess up, Mom? 88 plus 66. 150. Oh yeah, you're right. See, that's why I shouldn't be math in my head. Especially before my college. All right, so with number 4, again, basically just reading the graph here, between 2 and 4 seconds. So our initial position is 50. Okay, our final position is 4. All right, so our total displacement here is negative 46 meters. Okay, between 4 and 8 seconds, we go from 4 to 33. Okay, so we're looking at negative 37 meters for that one. And then between 12 and 16 seconds. All right, so at 12 seconds, we are at a position of 20 meters, and at 16 seconds, we are at a position of 12 meters. All right, so we're looking at negative 8 meters during that. Okay, some people have done number 5 with the distances for the same times. Okay, I'll give you a little bit of time. All right, so on number 5, we're looking for the distance traveled between 2 and 4 seconds. Well, it actually doesn't change. It's just not negative. Yeah, it's just 46 meters. Okay, the only time distance is going to be different from displacement is if there's a change in direction. Okay, then it'll be different. But as long as it's a straight line in all one direction, they're going to be equal. All right, between 4 seconds and 8 seconds. All right, so we're going from 4 to 33, so that's still going to be 37 meters. That doesn't change. But 12 to 16 seconds will change because there's a change in direction here. Okay, so we have to go up to, so we go from 20 to 26. No, 20 to 27, sorry. So this is 7 here, and then we go back down to 12. Okay, so from 27 to 12, 15. All right, so we're looking at a total of 22 meters there, if I'm reading the graph right. Okay, how many people have done number 6? Okay, I'll give you a couple minutes on number 6 then. Okay, let's have a look at this one here. So for our velocities here between 0 and 2 seconds, right, remember that velocity is displacement over time. So for these ones, we're going to be going final position minus initial position over time. So between 0 and 2 seconds, okay, we go from 30 to 50, so that's 20 meters. That happens in 2 seconds. So 20 meters over 2 is 10 meters per second, positive, because it's vector. Okay, between 2 and 4 seconds, okay, between 2 and 4 seconds, we go negative 46 meters, okay, and that takes another 2 seconds, so 46 over 2 is negative 23 meters per second. Okay, between 4 and 7 seconds, so this is one we haven't had yet, okay, and the 7 seconds is kind of a tough one because it's right in the middle of 2 grid lines, okay, but we're looking at negative 24 is the position there, okay, and we started at 4, so we're looking at negative 28 meters, and that takes over 3 seconds, right, so whatever 28 over 3 is. Okay, so negative 9.3 meters per second, and then between 9 and 11 seconds, so same thing here with 9 seconds, it's kind of right in the middle of 2 grid lines, okay, but it's right there. So we're looking at negative 42 going back up to 0, so we got positive 42 meters there, divided by 2 seconds, we're looking at positive 21 meters per second for our velocity on that one. Okay. And guys, this is exactly the kind of thing I would ask you to do on a quiz or a test. Here's a graph, read it, interpret it. Okay. There could be a question that says, what is the object doing between 4 and 9 seconds? Okay, and it would be traveling backwards at a constant velocity, things like that. Okay, those are the types of things you can expect. All right, remember that Monday your graphing labs are due.